Okay, so this is 5.1, operations on polynomials. Should be pretty much just a review for you. Polynomials, if you remember, have one or more monomials put together by addition or subtraction. There's an example one. You just need to remember that each exponent must be a whole number. Oops, I forgot to put my pen. Must be a whole number. And the coefficients must be real numbers. You gotta know the difference there between them. Okay, so remember what a constant term is, the only term without a variable. Degree is the largest exponent of the variable. A leading coefficient is the coefficient of the degree term, the highest degree. Standard form, the degree term is written first, and each successive term's exponent decreases. So here, when we're adding and subtracting and multiplying them, just reviewing your memory on it. So when we're adding and subtracting, remember they have to be like terms. So you can rearrange them if you need to. If you can see it straight out, that's great. I'm fine with that. So I'm adding the a cubes together, so it gives me 12a cubed. Adding the a's together, we would get plus 6a, and then minus 2. On the subtraction ones, I would suggest kind of rewriting this one. I know a lot y'all don't like to do a lot of writing. I don't either. But I find when students distribute this negative and write that step, they tend to do better and not make less mistakes on it. So we're distributing that negative to everything in that second parentheses there. So then we can add our like terms. That means the x to the fourth together. So let's see, that would be 3x to the fourth. There's only one x squared, so minus 7x squared, and then plus 9. So if you don't need to write that step, that's fine, but I would suggest it, especially if you're concerned about mistakes, like especially on a test. All right, then number 3 here is just multiplying. Now this is distributive property because you can't really use FOIL because there's 3 terms in that second one. So there's a couple ways to do this. I just prefer to take the first term and multiply it by everything in the second one, and then do the same thing with the second term, and then just combine all my like terms. So, but if you do it a different way and you're getting it the correct answer and showing your work, I am happy. So 7n times all of that would be 7n cubed plus 42n plus 21n. Oh wait, that's n squared. Okay, right there. And then the next one, we would do 1 times everything, so plus n squared plus 6n plus 3. So then we add our like terms together, we get 7n to the third. This would be plus 43n squared plus 21 and 6 is what, 27n plus 3. All right, so in the next part, we're going to be looking at factoring. And I know we did some factoring earlier in the year, so this is probably just looking at a little bit more detail. Remember, when you're factoring, the very first thing you should always do is look for a GCF and take that out first. But we're also going to look at the difference of squares, factoring by grouping, quadratics with leading coefficients, and quadratic form. So let's look at the first one, the difference of squares. This kind of focuses just on difference of squares. So first of all, I'm noticing that there is a GCF of t. So if I take out a t, I'm left with t to the fourth minus 16. Well, on this one, that is a pattern. That's the difference of squares. So this would be t squared plus 4, and then t squared minus 4. But here's the kicker. You notice that, let me see, go to a highlighter here. Notice that this piece is still a pattern, okay? You got to watch for that. So there is another step. So this would be t times t squared plus 4 times t plus 2 times t minus 2. So you got to make sure that you're going far enough out that you're actually going all the way and factoring it and simplifying it all the way. All right, so on this next one, if you want to pause and try it yourself, you can pause and try it yourself and then come back and see if you got the answer. I'm going to go ahead and get started here. this would be 9x plus 10y to the fourth times 9x minus 10y to the fourth. It looks like we might be able to keep going there, but we can't because there's not perfect squares in that second one. So this is actually our answer. We are done. On the next little part, we have grouping, factoring by grouping. So remember, if there's 4 terms, I don't see any GCFs in common, so there's nothing I can take out. So this is where you group the first 2 together, you group the last 2 together. Remember to keep the signs with the parts. Okay, I see a lot of people mess up on that. Then we factor out each one separately. So let's see, 56v cubed minus 49v squared. They both have a 7v squared in common. So this would leave me 8v minus 7. Here I could take out, let's see, I could take out a 6, right? If I take out a 6, it gives me 8v minus 7. And one thing I want to point out, you see how this parentheses and this parentheses match? They have to. If they don't match, you can't actually use factor by grouping. Okay, so now we look at each term separately. They both have a 8v minus 7. So if I factor that GCF out and put it in the front, I'm left with 7v squared plus 6. And that is factored all the way. Oh, wow, look at number 7. Doesn't that look like fun, y'all? Okay, so across the board, is there anything I can take out? Probably. But that's a mess. Okay, let's see. They all have a d squared. And they all have a 3. So let's take out a 3d squared and see what is left here. All right, so in this first one we have 14a squared c plus, let's see, 147 divided by 3 is 49a squared d minus 12xc minus 42xd. Wow, that's a lot of stuff there. Okay, so now let's look. We're going to have to group. So I'm going to just keep this one in the front. And I'm going to group the first 2, 14ac squared, a squared c. It's kind of hard saying these. Okay, and when I go to group them, notice I'm keeping the negative here with that second group. Okay, keep it on the inside. I find people sometimes want to put it in between right here, and then they mess up the sign. So keep it with the number. We may factor it out. Most likely we are going to factor it out. But I want you to keep it separate. All right, so in this one, I'm keeping my 3d squared in the front. And let's see, I'm going to look at that parentheses. What do they have in common? There's a 7a squared. Okay, so 7a squared. And I'm left with 2c plus 7d. Let's see, I need to make this parentheses match, hopefully. If I take out a negative 6x, I would be left with 2c plus 7d. All right, so let's clean this up a little bit. If I look at this part and that part, what do they have in common? They both have a 2c plus 7d. And then what's left, if I factor those out, would be 7a squared minus 6x. Ooh, yeah, that looks like fun, y'all. I'm sure you're loving it too, right? All right, let's see what the rest of this lesson has in store for us. All right, so operations on polynomials. Let's check and see what that is. Let's see. Can we factor out anything here? Oh, yes, I believe we can. We can take out a 3. So that would leave us with 3r squared minus 22r plus 35. Let's see if we can figure this out. I know 3r, okay, and r here. 35 35, can't be too many choices, right? It's 1 in 35, which I don't think it's that. 5 and 7, that's like the only choices. So, okay, let's see if I can figure it out. They're both negative. They got to add to get 22. Oh, I see it. I think if I put a 7 here and a 5 here, because that would give me negative 7r right there. And then this part would give me negative 15r, and that together gives me negative 22r. So yes, that works. Awesome. Okay, so let me erase this. Alrighty, so we are done on that one. It is factored. Sweet. That wasn't so bad. Okay, so on the next one. On these in quadratic form, let's see. I know I got to factor out a negative in the front, right? So if I take the negative out, can I take a 3 out? Yeah, I can take a 3 out. So this would be x to the 4th minus 8x squared minus 9. Okay, so a lot of people have trouble seeing it with x squared and x to the 4th. What you can do, and I'm going to write this on the side, is let u be x squared, okay? So that whatever is with that middle part is what you're letting u be. So if we do that, and we can rewrite this as u squared minus 8u minus 9. So now it's a little bit easier to see. You just got to remember to put your x squared back in after. Okay, so this is negative 3. This would go to u minus 9 and u plus 1. But then we got to put x squared everywhere the u is, right? So this is negative 3. X squared minus 9, x squared plus 1. Oh, look at that. That's still a pattern. You see that? This is still a pattern. That's one of the patterns from before. So we need to make sure that we put all of the steps and factor all the way. So this is x plus 3, x minus 3. But this last one is not a pattern, so it stays. So, ooh, there's a lot of steps on that one. All right, so this next one has a little guy here, so you're supposed to work it out yourself. If you want to, you can. It's there for you to figure out. You can just pause the video, work it out, and then come back to it in just a moment. Let's see. This one is going to be, let's see, if I let that be u and that one v, factor 15. Got to subtract to get 2. Oh, that's 5 and 3. Okay, so this means we have a squared minus 5b squared, and then a squared plus 3b squared. So that is our final answer. If you can see that right off the bat, wonderful. If not, you can just go like, let u be a squared, and then say, I don't know, v or some other letter if you don't like v equal to b squared. And then you might configure it out. If you need more help, we can talk about it when we get to class tomorrow. Hopefully we'll be in class tomorrow. All right, so we'll keep going. Zero product property. Remember, if you have a times b equals 0, then that means either a is equal to 0 or b is equal to 0. One of them has to equal 0. So if you had something that was factored, then you would just use your zero product property and set each one of these things equal to 0 and solve to find out your answers. So that's like the nice things about factoring. You can easily get answers, so we know x is 0, x is 4, x is negative 5/4. So using the zero product property is the reason we learned to factor, and that's what we're going to do in this next example. So find all the solutions. So when they're saying all, you might have imaginary ones, but you've dealt with that before, so it shouldn't be too terrible. So notice we're looking for a GCF on number 11. They all have an x squared in common. So if I factor that out, I get x cubed minus x squared plus 3x minus 3 equals 0. Oh, now I'm going to have to use grouping. So I'm going to put my brackets up. I'm going to group the first two together. And then I'm going to group the second two together. And bring everything else down. Factor out the GCF of each one separately. So the first parentheses, I'm taking out an x squared. Second parentheses, I'm taking out a 1. Notice that these two parentheses match, and they should. If they don't, you got a problem somewhere. Okay, so that means if we look at this chunk and this chunk, what do they have in common? They both have an x minus 1. Okay, so x squared times x minus 1. And then if I factor out that GCF, I'm left with x squared plus 3 equals 0. So now using my zero product property, I know x squared is equal to 0, x minus 1 is equal to 0, or x squared plus 3 is equal to 0. So here I would take the square root of both sides, so x is 0. Here I'd add 1 to both sides, so x is 1. Here I would subtract the 3 and then take the square root, so now x is equal to positive negative I square root of 3. Because remember, if you have a negative and you're taking the square root, you got to take that I out. So when they say all, so just watch out for the wording, okay? If they say all, they're including the imaginary ones too. All right, so here's this little guy again. So if you want to work it out and pause me and see if you get it right, you certainly can. And then come back and check your answer. That would be great. So on this one, first thing I want to do is get everything on the same side. Standard form, remember, it has to be in standard form. All right, so let's see, GCF is an x, so I can factor out an x. So if I factor out an x, I'm left with 5x squared minus 7x plus 6 equals 0. Alrighty, so, oh, that's yuck. It doesn't even factor. Oh, maybe that's why they put this. Look at that. It says, if possible. Wonderful. Okay, so it's not possible. This one doesn't factor. But it is quadratic, so it means I can use the quadratic formula. So that would be negative 7 plus or minus square root of negative 7 squared minus 4 times 5 times 6 all over 2 times 5. Notice how that came in from the previous lesson. That's why we did it. Okay, everything we do is there's for a reason. So this would be 7 plus or minus, ooh, I'm going to need my calculator. Okay, so 49 minus whatever that is. This is 30 times 120, so this would be negative 71, I think, if I did the math right. And this would be 10, obviously, on the bottom. All right, so this is imaginary. Okay, so I know I've got x equal to 7 plus or minus I square root of 71 over 10. Okay, that's 2 answers right there, guys, even if they're imaginary. But don't forget about this one right here, that x that we pulled out. A lot of people forget that on the test, and they won't put, well, I know x is 0, and then they'll miss that answer. So just be real careful with that part. All right, so the rest of this package is for you to work on your own. You will have some time tomorrow in class to work on it also, but just do what you can, and then we'll talk about it, and I'll answer any questions you have in class tomorrow. Hopefully we'll be there tomorrow.